My name is Henrik Andersen. I'm here this evening in my capacity as the chair for the Energy Institute, CUI Network and Forum. My day job is as Materials Corrosion Inspection Engineer and Team Lead for Shell in Aberdeen. And I'll be hosting the proceedings this evening on behalf of the Energy Institute. The Energy Institute, CUI Network and Forum was revived last year in response to the continued issues that the Corrosion Management Committee and team members of the Energy Institute brought up on a recurring basis. The network and forum is set up to bring facility operators, regulators, operators and technology providers and contractors together to share information and development to the benefit of all. We meet about twice a year. At the moment, obviously, all meetings are virtual, but we hope in the future to be able to meet face-to-face again. If any of the companies represented here this evening are interested in knowing more about the CUI Network and Forum, please reach out to your Energy Institute focal point. So let's get moving this evening. Do remember to post your questions, comments in the Q&A box, and to whom you're asking the questions so we can get these picked up after the presentations. We'll have a panel discussion around about 6:50, and then we'll run till about 7:30. So without further ado, let's get going with the first presenter. Rebecca is Head of Emissions Reductions at the OGTC. As we are moving towards an ever-approaching net zero targets, but has also a keen interest in all things integrity related. Rebecca is also the chair of the Aberdeen branch of the Energy Institute. Over to Rebecca.
Thank you, Henrik, and welcome everybody, and thank you for joining us on this cold and wintry evening up in the northeast of Scotland. Now, I'm going to attempt to share my screen, which is always a bit of a challenge for somebody who works at the Technology Centre, but here's hoping it works. And I will give a bit of an intro on why we're still talking about CUI. So just to reiterate what Henrik says, so I am emissions reduction or head of emissions reduction at OGTC, where we're predominantly working and supporting new technology developments to overcome industry challenges. I'm also the branch chair for the Aberdeen and Highlands Energy Institute branch, and I've been working with the team over the last year or so. Once we found it, we know how to deal with it.
It looks as if Rebecca is having a bit of IT issues. So we're back. Rebecca, we lost you for a second there. We can now, yes.
Okay. So I was saying, why are we still talking about this? Hopefully you picked up some of what I've been trying to get to. So we have guidance notes, we have best practice, we have inspection techniques, but we also have, once we found the problem, we know how to repair and replace. So if something goes wrong with Apple, you might not be able to use your phone, or you can't log in for a few days. It's very inconvenient. We also, just again picking up on the news today, the Co-op and Morrison's have problems with their cardless, contactless payments. It's an inconvenience. But if we get it wrong and we mess up, people can die. And that, to me, is why we should be working to reduce this problem. The other thing that I think has been really challenging as well, and again, why we're talking about this, is very much around, if anybody's been aware of the CUI over coffee sessions that the corrosion radar guys have been doing last year, they, as part of their ongoing discussions, surveyed the industry to see where they thought their CUI management was. And over 95% of the industry responded to those surveys to say that they felt the CUI management programs were inadequate and needed to be transformed. So again, the reason why we're talking about this, because the industry itself believe we don't have a handle on this yet. It comes down to three main things. We need to be able to predict better. We need to understand where the problem is going to occur and when it's going to occur. So using data, standardizing the data, sharing more of the data across the different platforms and operators, and then being able to do some continuous monitoring prediction analytics. So using the data side to really help us predict where CUI will occur. We should also be looking at the monitoring. So the sensors, and there are sensors coming out, and the OGTC have been funding several projects looking at sensors, from the corrosion radar sensor to one project with Inspection Technologies looking at moisture detection or early signs of corrosion. But again, the challenge we have there is, can it be retrofitted? Can it do wide areas? And is it cost effective? Late life, brownfield sites, that is the key challenge. It's not about the sensor itself, it's about that low cost, wide range and retrofittable. And then the other part is still down detection. We do have a suite of technologies that are available to help inspect and detect, but we should still be investing in new ones, pushing that norm, looking for new techniques. And again, that's some areas that we're looking at. So just to really finish up, and again, if you're aware of some of the work I've been doing within the OGTC, 4 years ago when we first started, when everybody says CUI is the big problem in the industry, we need to rectify it. We made a statement and a goal to say we will eliminate failures due to CUI by 2026. 4 years on, we're not anywhere near ready to say we've made an inroads to that. So to me, that's why it's important and why we still talk about this and actually move from talking into some action and hopefully bring new technologies, new ways of working, management of change into the forefront to say, let's manage this problem once and for all. So I'm glad to see the CUI network's been resurrected, and Henrik's now looking after that as chair, and hopefully as an industry we can start working way through new initiatives. Us as the OGTC will continue to develop and invest in technology, and we will be publishing some results of the technologies coming through later this year. And also, if you're out there in the development community and you see things, know things, or want to try and push new technologies through, then by all means, speak to ourselves, and we're more than interested. So that is my part. I believe we have had some technical issues, so hopefully you've got most of it. But like I say, if you want to discuss it in more detail, please reach out and either at Q&A at the end or offline at a convenient time. So back to you, Henrik.
Thank you, Rebecca. Yeah, we did manage, though there was a few IT glitches on the way, but we got there in the end. So good. Thank you very much. Remember, everybody, any questions, comments, anything, reach out now, add it to the Q&A tab, and we'll get back to it in the panel conversation later on. Now, next up is Yvonne, who is the chartered engineer and also the advisor for the branch. She's an engineer. She has an engineering background, highlighted with the MSc that she's got in oil and gas engineering, and a postgraduate certificate in corrosion control engineering. Yvonne, please.
Hi everyone, my name is Yvonne, and I will be presenting on the second section of this webinar. So basically, corrosion under insulation, why are we still talking about it? For me, I think we're still talking about it because the challenges presented by CUI have not actually changed. You know, this topic has been well talked about, has been well researched, and you know, progress has been made, but I'm not sure if a step change in improvement has been made. So basically, what is CUI? CUI is the external corrosion of pipework and vessels that occurs beneath insulation following water ingress. Can you all hear me? Hello?
Yeah, we can hear you just fine, Yvonne.
Okay. So CUI is the external corrosion of pipework vessels that occurs beneath insulation following water ingress. This water could be in the form of, you know, could be from rainfall, it could be from deluge, it could be from steam discharge, it could even be from condensation or sweating. And there are industry guidelines and practice on CUI, and these include API recommended practice, API 583, corrosion under insulation and fireproofing. We have NACE, SP0198, control of corrosion under thermal insulation and fireproofing material. We have the Energy Institute guidelines for the design, installation, and management of thermal insulation systems. And we have the EFC Working Parties 1315, which talks about corrosion under insulation guidelines. I must say the API 583 talks about like your design and the inspection and the mitigation and of corrosion under insulation for pressure systems. So we keep talking about CUI challenges. You know, why does CUI present so many challenges? For me, it's because we're dealing with a lot of factors or a lot of, you know, parameters. You know, we're dealing with inspection, we're dealing with temperature, we're dealing with moisture, contaminants, costs, maintenance requirements. So for example, if we pick on temperature, for example, you know, CUI occurs at a wide range of temperatures. So if we are looking at carbon steel, you know, we can get CUI from temperatures of maybe -4 degrees centigrade up to 175 degrees centigrade, although the highest probability would be at temperatures of around 30 to 120. And if we are looking at our corrosion resistant alloys, you know, you can get CUI from 30 degrees centigrade up to 200 degrees centigrade. And I must say that the manifestation of CUI in corrosion resistant alloys is like in the form of stress corrosion cracking or chloride pitting. If we pick on the contaminants, you know, contaminants, they increase the conductivity or the corrosiveness of the water environment. You know, these contaminants, so I'm talking about like your chlorides and your sulfates, you know, they can be external to the insulation or they can be leached from the insulation. And then when we look at maintenance requirements, you know, we're looking at maintenance of the external coating, we're looking at the repairs that need to be carried out on the cladding system. So all these things impact on CUI, but for the purpose of this webinar, I will just, you know, pick up on a few of them. So if we're talking about costs, you know, CUI presents a high expense in terms of failures, remedial, deferment, and inspection activities. According to the Oil and Gas Technology Center, about 20% of major incidents in oil and gas industry in the European Union region since 1984 has actually been attributed to CUI. And even in the North Sea, you know, more than 60% of pipework failure is actually due to CUI. And if we look at the next, you know, point that I put in there, we have the justification of the cost benefit in adopting new non-intrusive inspection technology. You know, for me, to date, experience has shown that 100% delogging and visual inspection is the most effective method to provide a current baseline condition from which a CUI, RBI, and maintenance strategy can be developed. And also in practical terms, it may be more useful to compare the cost of NII versus insulation removal, because the latter can actually be competitive if it's done properly or if it's well organized. Also, CUI is a complex system. You know, we're looking at a lot of contributing factors. You know, we're looking at your water ingress, your temperature, your design. And, you know, most of these environmental factors are actually impossible to control. So if we're looking at your cumulative wetting, it's unpredictable. And because it's unpredictable, it impacts on the coating life, it impacts on the remnant life of the equipment. And then we have, you know, CUI can be very localized and it can occur anywhere. So this picture that I've attached to this slide is basically CUI on a pipework that is located in an internal module, you know, like it's in an enclosed module. And this pipework is located in the roof, you know, so, but when insulation was removed, you know, we have CUI. So what happened? Basically, we know water can, can sort of like move underneath insulation and be collected by, associated pipeworks and be deposited, elsewhere. In this case, in this enclosed module. We also have issues with detection. External appearance of the cladding may not correspond to the condition of the underlying pipework. So in some cases, we might not even know we have CUI until the insulation is removed, or until corrosion, gets to a stage where a failure occurs and, and we get a leak. And then if we talk about the non-intrusive inspection, NII, we do have some of them. We have your radiography, we have your long-range UT, we have your pulse eddy current, guided wave UT. But these have got certain limitations, such as detection capability of the tool, the cost, the speed, the inconsistent results, the individual interpretation. So for example, if we pick on radiography, for example, it can be slow, it introduces extra hazards, it requires scaffolding. If we're looking at long range UT, it's basically used as a screening tool, to direct where you can, strip off your insulation. If you're looking at pulse eddy currents, it will detect gross defects, but maybe not so on minor defects. So yeah, detection it can be a bit challenging. And this slide talks about, now that we've talked about the challenges, how do we manage CUI? A structured approach is required to mitigate and predict the effects of CUI. I've broken this down into 4 sequential elements. So the first one I've called identification. It basically involves elimination and reduction of the CUI risk. So here we're talking about insulation removal. It could be full, it could be partial. This is normally done with an input from the process engineer. So for example, in your full insulation removal, if insulation is required for, say, personal protection, that can be removed and, cages installed. With partial insulation removal, we're talking about removing insulation from prone areas on the pipework. So maybe from the small bore connection, from the pipe supports, from your vertical to horizontal bends. This has actually been, it's been shown to be quite effective, because it kind of like focuses, the CUI detection on discrete areas. And in this section, we also need to look into using better insulation specification. Then the second stage is carrying out your likelihood of failure or probability of failure. And, there are a lot of inputs into this. You're looking at your temperature, you're looking at your metallurgy, you're looking at your external environment. All these can have, are sort of like input parameters into probability of failure detection. And there are several methods of doing this. And, I think all of them would work well, so long as, the limitations are actually made known in the final risk assessment or, risk assessment. And the third section is we're looking at, I've called it assessment. So we're prioritizing our inspection. This is based on the criticality. So you're looking at the inventory, you're looking at the pressure, and also historical information, / data. I have to say this has got to be done efficiently, because there was a failure that occurred, I think 4 or 5 years ago, and it was due to CUI on a pipework that had high pressure methane gas. And, the pipework wasn't ranked high enough. It was actually ranked as low. And because of that, it wasn't prioritized for inspection and it failed. And I think the company involved was heavily fined because of this. And the last is what I've called mitigation. You know, you're defining your inspection scope. You're defining the kind of inspection you're going to carry out. You're defining your periodicity of inspection. You're defining your coverage. For me, I think inspection plays a very important role in CUI because more than in other corrosion threats, because it's only through inspection that you can actually monitor your barrier, the condition of the external coating. So basically, this approach that I've shared with you summarizes industry guidelines in minimizing the impact of TUI on our facilities. Of course, there are always opportunities to enhance every aspect of this approach. Thank you very much.
Thank you very much, Yvonne. And again, any questions, comments to Yvonne in general, anything, please put it in the Q&A box and we'll get to it at the end. Okay, so now for our final presentation of the evening, which is Jim. Jim is the Principal Engineer of Oceaneering Integrity Management and Digital Solutions. He is responsible for developing numerous NDT techniques and evaluating various technology solutions for both topsides and subsea NDT integrity and inspection related issues, including condition monitoring options. So Jim, over to you, please. And again, everybody, questions in the comment box, please. You okay, Jim?
Yeah, I can hear you, Henrik. I'm just going to share my content, hopefully. How's that?
Yeah, that's fine. We see your screen. We see it in present. We don't see it in presentation mode. Yes, if you click that, that's it in presentation mode.
How's that? Right, fine. Thanks very much for the introduction, Henrik, and thanks to Katrina and the Energy Institute for organising the event and giving us the opportunity, really. Hopefully the presentation will be of some interest. FSCT, Focused Stress Concentration Tomography, a bit of a mouthful, even for me. And the project is really still under development with the main partners who are Spear Hunter and Oceaneering, and we're supported by Repsol, Sinopec, and ultimately OGTC are providing most of the funding. We're at the latter stages now, whereby data gathering and analysis with the equipment prototypes has the greatest emphasis. The technology stems background on FCT technology. Just a quick background. The technology stems from an existing service provided by Spear Hunter called SCT. It's magnetometry based, and it's an integrity inspection tool for mainly for buried pipelines, whereby the pipeline remains in operation. So there's no really any need to shut down the operations. It consists of somebody wearing the inspection tool, walking over the buried pipeline over desert or farmers' fields or inner city roads, anything that's non-magnetic between the inspector's feet and the pipe under examination. The inspection tool has very sensitive magnetometers, and it kind of absorbs the data from the pipeline. There's no energy induction at all, like traditional ultrasonics or radiography or radiation, ultrasonics or pulsed eddy currents or anything like that. There's no actual energy induced into the pipeline. It's really a matter of listening, if you like, to the background magnetic field changes which happen around localized flaws in the pipe, which has suffered pressure usually. As I said, the magnetometers listen to these changes and interpret them as SCZs, which stands for stress concentration zones, and it's expressed as a percentage of the SMYS. I'll talk about that in the next slide. Offline analysis of the collected data delivers the SCZ location, i.e. where that magnetic anomaly has occurred, and it gives a severity and a pipeline route, i.e. location, and an approximate depth of burial. And next bit, there we go. Just as a quick one, the conventional large standoff SCT delivers the results in this type of format where it highlights the stress concentration zones, which are in fact readings derived from the small magnetic field changes in a pipeline under pressure or not, or has seen pressure. This is actually called the Villeray effect, and it's expressed in a percentage of the specified minimum yield strength. This particular example here is a case study of the SCZ as it occurs, the SCZ based excavation, and Dave actually knows a little bit more about that. Dave, you online just to tell us what happened with this?
Yeah, Kendall, thanks, Jim. This is really just to give everybody a background to the technology and how the success of the standoff technology has led to its adaptation for focused and for finding the specific CUI problem. So here was an example of a pipeline that we inspected in Europe. The inspection was completed. Offline analysis results, as Jim said, were completed. And it's quite difficult to explain, but the second left-hand graph, you can see with the yellow circle, they're highlighted high-level stress concentration zones. So we knew at this particular area along the pipeline route, there was localized elevated stresses relative to the rest of the pipeline. The line at this particular point was then excavated, having had DCVG coating inspection completed along it. At the same area, there was a DCVG coating fault reported. During the excavation, you can see in the photograph there, we found deep corrosion at the 12 o'clock position along the pipe, but interestingly, the corrosion actually spread. If you can see in that graph that I pointed to on the left-hand side with the bars and squares on top, a number of stress concentration zones longitudinally along the pipe. This particular area of corrosion extended 10 meters past the defective coating area. So really, this is just to give you an idea of one of the previous successes on which we're basing this adaptation of the technology.
Thanks, Dave. The new initiative really centres on a CUI solution, and if you look to the right, you'll see Mr. Ed. I don't know if some of you may be too young to remember the talking horse that used to be on the television, but Mr. Ed is on the right-hand side there, and this new technology is based on the SCT technology, but it's focused, or it's blinkered from external magnetic influences. And so the idea is really just to focus the listening for the magnetic anomalies in a specific area rather than more generally as SCT does. The objectives for the project were a quick screening tool. It had to be non-intrusive, obviously, a passive technique, as I explained before. There's no energy induction, no insulation removal, and a real-time result where it categorizes results into severe, moderate, and minor. We're wondering whether at the moment they change that just to two categories, whether just corrosion or no corrosion. But we're at that stage, but we'll need more data to decide on what categories to do. But it had to essentially have a high probability of detection. The project began in July 2019 and it should be completed next month. The electronics and the software analyze data in real time delivered by the thing on the left-hand side is a handheld single probe, and on the right, well, the left-hand side, the handheld single probe is a bit similar in style and operation, sorry about that, to PEC inspection, to be honest. So it's just a single probe. We're going to try and make it wireless as well, so there's no trailing leads. And the thing on the right-hand side is a probe array, ring-shaped to fit different insulated pipe diameters. At the moment, we've only got one that fits a 6-inch, but the results will be presented to the operator at the time on the tool and on a palm top, which a second person will have associated with the FSCT operator. And I'll also present this type of data, this topography that's in the middle, the blue bit in the middle, will present the data like that. So typically that would show us, or any stress concentration zones would show up as these kind of mountainous areas in the middle. So that's the kind of way that we want to present the data, real time and very simple to interpret. Our initial handheld probe in action at St Fergus. Note that the gridded bands that I've put around the pipe there just guides us where we want to put the probe so we can ensure coverage. The buttons to oh, I don't know what happened there. The buttons to operate it are you can maybe see above my fingers there, are on the probe itself. It's ruggedized IP65. It collects 20 samples per second, is what we've estimated, and that's the kind of coverage area. The data is collected in circumferential and or axial direction. We're actually thinking that the axial direction seems to be a better way of collecting the data. It's currently been tested in 4, 6, 8, 10 and 20-inch diameter pipe samples, mainly on corrosion that was found previously and had some reparations. So we're looking for samples that have actual corrosion that have not been repaired to test it on. It's also been tested at 5 meter diameter pressure vessel, currently tested up to 65 millimeters insulation thickness, and thanks to Repsol, Sinopec and Shell for allowing us to get to their to float in St Fergus to try it out. But the red writing at the bottom is it requires extended data gathering and analysis, and we're still at that stage. You'll see this is the circular, it's a short clip showing the real-time nature of the results. If you look up the right-hand side there, you'll see the results being fed back in real time as the probe scans across the CUI. Although it's not got any insulation on, you can see the principle of operation that result is shown in real time. But note this is only a single probe that's put in this ring. That's how he's having to revolve it. The eventual tool will have 4 probes in the ring, and that will give data, and it will just move axially and it won't have any circumferential movement. Third last slide, I think it is. To summarise, the development project needs access to a lot more pipes and vessels with real CUI, and this is what we're asking for your help in here as well. We need as much data possible from operational environments to improve both the hardware and the software. It's all about training the algorithm. So we need to test a variety of diameters, a variety of insulation thicknesses, a variety of insulation types. And what does focus really mean? Will we be able to go over a pipe support because it's going to have a magnetic influence in the signal? Parallel pipes, we need to try and test that as well. But the bottom line is the technology will definitely see the corrosion. It'll definitely get a signal, but we need to train it to tell it as to how severe that signal that it detects how severe that signal is in terms of remaining wall thickness. We've got a little, this is probably as a reminder, as if you needed it for the costs to the industry. You can look that up, you've already got the slides, but that's just giving you some millions. But the main thing is the cost to the industry, especially to the health and safety of our people. The last slide here is just a short animation. We've done, I'll try and turn the volume down there. Are you still okay to hear me there? Hopefully. Is that animation coming up okay, Katrina?
Yeah, we can hear you, Jim.
Yeah, the animation, I'm sorry if it's a little bit bitty, but it's showing you the principle that there's corrosion underneath that insulated pipe. One operator has a light telling you it's green, everything's okay. You'll see the light change to red on the tool and on the palm top computer. When it comes to a pipe support, we can go to the other side, but we fill in the bit where the pipe support prevents the circular tool by using the handheld tool, and it works on exactly the same principle, where it goes from red to amber to green. So same again onshore, same tools onshore. The reason we stuck this little bit in was to show you that the handheld tool, see it going there from amber, it might go to green again to see it's okay, but we can also use it on vessels and larger diameter pipes, given the same principle. We would have gridded that vessel up, the only thing I missed out there. So thanks very much for your attention, and I'll just end that show there and hand you back to Henrik. Thank you very much.
Thank you very much, Jim. Very interesting, and thank you, Dave, for your contribution as well. We'll now go to the open forum for questions, and I'd like to officially welcome Dave into the conversation, and also Hamid Habibi from Spear Hunters, and they will help with some of the challenging questions that you can ask. So please keep the questions coming. And so I think while we got Jim on the flow of his presentations, there's been quite a few sort of quite technical questions come in regarding the technology and that Jim is presenting. So Jim, one of them is how will existing embedded stress concentrations from welds, bends, etc., affect the results of what you see?
It will certainly affect the signal, and we should be able to tell the difference between welds and other things. But I'm going to ask Hamid to ask his opinion on just exactly how it would affect it. Hamid?
Yeah, sure. If you're talking about Focused City, yes, definitely we see the girth welds. But I think the question, I've seen it on the panel, was about the CT in general. And if that's the case, any of those residual stress from manufacturing or anything else would remain there. We see that as a localized stress, and we report. But generally, when we have a defect, the stress levels are higher than those from the manufacturing of the welds.
Okay, thank you very much, Hamid. And Jim, one more question around the SCSET, the stress concentration part of it. And it's asked, does it detect defects all the way around the circumferential of the object, or is it just what it can see from where the probe is?
Okay, actually we report localized stress. So obviously we can't tell which clock position it is, or where for example the exact location of the CZ is. What we do is we report the geometric center of localized stress, and most of the time that actually is associated with a metal loss or something else. So it's not precise. Also, it's a good opportunity to explain it's different from Focused City in this respect, because when we have a localized stress, the effect could extend to about 3-4 meters. But with the Focused City, we see the precise location of the corrosion under insulation. So they are, although the principles are similar, they're totally different in terms of the data analysis.
Yeah, I think it's a good question, that, actually, Henrik, because the original project, the attraction of the original project was because we have lots and lots of parallel pipes and refineries and all over the place. Then, and there's not always access. Then the original objective, one of the original objectives, was only to inspect from one circumferential position and be able to see the whole 360 degrees from one or two circumferential positions. So we didn't need that circular probe that we saw there on the animation, but we found that it's actually bitten us in the bum a little bit, because we're so close to the pipe, sees the magnetic influences from the near wall directly below the probe, whereas SCT in its original form, the large standoff SCT, it sees a pipe as being one magnetic influence. So it's so far away, it just sees the whole pipe as one magnetic influence, whereas because we're much closer to the pipe, we're seeing the influence of the near pipe wall an awful lot more than we would in the original technology. That was something that we didn't expect, but something that we're working through just now.
Okay, thank you, Jim. On the technology, it looks very impressive, I must admit, and we've certainly seen the trial at Upper St. Fergus, and it does give some very impressive results. But where do you think it sits in terms of development, and when do you expect it to become an off-the-shelf offering?
We're very much, at the moment, we're very much at the data collection stage, and we are begging for operators to give us an opportunity to go onto sites to collect data. But unlike the way Oceaneering has anyway, and maybe other service companies have introduced new technologies before, where operators are always extremely cynical and they ask for, we want a blind test. We know, operators will typically say, can you test that bit there, then bit of pipe there, then we'll take the insulation off and see if you were right or not. We've came at this at a different approach. What we're saying is, we know the machine will pick up signals, but what we've got to do is teach the machine as to what is a serious signal and what is not a serious signal. What is serious corrosion and what stuff can we ignore? So what we're going to be doing in the first quarter of this year, and Dave will correct me where I'm wrong, but second quarter of this year, is actually go to an operator site, and who already have an insulation stripping program already in place, and we're going to follow the insulators around, and whenever they take insulation off and there's corrosion there, we will be right there to take data, put the insulation back on again, and take data again, so that we are not wasting any time looking at areas and spending time looking where there isn't any corrosion. We're going to be teaching the machine at that time on specific areas. So that's the way we're going to train the machine. And, hopefully, there'll be a bit of artificial intelligence added on at the very end. Dave, have you got anything to add there?
Yeah, in terms of the actual development of the tool so far, like Jim said, we have a tool that works now. So we have a tool that if we took it to site, we would find corrosion. The problem is we wouldn't be able to categorically say this is corrosion. The main next stages of the project, like Jim said, are to build up the database to allow us to be able to effectively, like Jim said, train the tool to tell us what we are seeing and categorize, but also just as importantly is to determine what are the limitations on the tool. So as it stands at the moment, the tool will find a large area of CUI, but under what circumstances would it not find it? What are the insulation thickness limitations on us? What are the pipe diameter limitations? And all this requires a massive data. We need to be able to try it on something before we can say whether it would work or not. So in terms of development, that's where we're at now. We have something that works and can find it, but we really want to refine it to make it as efficient as possible for slipping into the CUI programs.
Okay. Thank you very much, everybody. Rebecca, A question relating to OGTC. So with the shift in strategy for the OGTC, so focusing more on zero carbon and the strategies around that, how will the OGTC technology integration that you've been supporting the industry with over the last, 4 years now or something like that? How will that look for CUI in the future? So
interesting that, and we have been asked that a lot over the last 3 or so months since we've shifted our focus. So we've gone from our traditional discipline approach to this net zero. And the big thing, and why I'm sort of still part of the emissions reduction piece, is about fugitive emissions, and CUI fits still into that. So in our new and revised updated roadmap, CUI is still one of the big technology priority areas because it contributes, as we've talked about as an industry, it's 60% of all pipe failures are associated with CUI. If you have a pipe failure, you're producing emissions. You've also got the safety thing, you've got production and all that, but it's still very much in that. If we're going to get to a net zero future by 2045, we have to keep everything that should be in the pipes. So CUI will still be part of that. And yes, and still a lot of work to be done in the area, which is why we're still talking about it.
Excellent, good to hear. Thank you very much. Another thing that came in for you, Rebecca, but I guess we can go a little broad and certainly get on in on this as well, is regarding coatings and aerogels and things like that. So the question was specific to coatings being used as mitigation. Have you done anything in OGTC regime for that? And is there anything and this was specifically in relation to aerogels?
So we haven't as such invested any project activity in this. We are aware, we have been talking to some companies with aerogels and the technology. I think it's one of these areas that there's reluctance for adoption, whether it's from the performance side as the unknown, has it got challenges associated with existing systems. So I'm interested as a technology provider and funder to look at new alternative systems. So aerogels are very much up there. And even when we went out for our call for ideas a few years ago on the whole CUI challenge, we did have a couple of technologies that were looking at aerogels, but we just didn't get the industry uptake. And a lot of us with our projects, when we fund them, they have to have the industry buy-in as well. So sometimes they're maybe a bit too early. So again, if people are in this space, they're wanting to discuss further, we will be more than welcome to come and chat to us about what options they have. But that's from the operators that are maybe trialing them and seeing what they're like, or from the development community to say, I've seen some, or I'm working on some areas, so come and speak to us. But I'm sure maybe Yvonne or others may have got insights into aerogels as well.
If I may sort of like jump in. For me, I would think, I don't really know, but I would think a coating that is resistant to thermal shock and cycling in wet and dry conditions would be ideal, but I don't know any coating, but that is what I think would be appropriate.
Yeah, it's definitely an area where there's a need to do a lot more research and a lot more investigation into what's possible and what we can do. Yvonne, while we've got you on the screen, what do you see as next, or maybe the first leap in technology for CUI support? Do you have any insights that you want to share with us?
A question for me, sorry, Henrik.
Yes, there was, yes.
Oh, sorry, what's the question again, sorry?
So is there anything that you see in the technology buckets that will help the CUI that you are specifically interested in?
I would perhaps love to see a technology that can actually monitor the coating condition, because like I said in my presentation, inspection, it's really important, especially with CUI, because that is the only way, we can know if there is CUI or not, and there is no barrier monitoring mechanism, for CUI. So if there's a technology that can actually tell us, oh, what is the condition of the coating under insulation, I think that would be fantastic.
Good. Yeah. So we have a question from Danny relating to picking, and he's saying, can we consider intelligent picking for measuring CUI? Rapid and comprehensive, but requires temporary breaking into a system, obviously. Any thoughts on that from the panelists?
From my perspective, I think that, I mean, yeah, looking at alternatives, but it's the breaking containment is usually the biggest challenge in there. But again, you know, we've talked about coatings and self-healing coatings. There's always an option to try and look at new ways of working and new technologies. So I think it's a lot of these are overcome some of the adoption challenges as well as just technology challenges needs to be addressed. But I think Hamid had something to maybe add to that as well.
Yeah, I just wanted to say that, yeah, definitely an inline tool could help here, but many of the pipes that has been proposed for this technology, they are mostly non-piggable or inside facilities, basically. So, yeah, I mean, that's obviously an alternative to this.
Yeah, absolutely. And most piping's got narrow bends, which you would not put a standard pick through, definitely. But
exactly.
Again,
I just want to add. I'm sorry to interrupt you. I think Focused City would be more sensitive, and also will pick up the conditions before even corrosion starts or it's in microscopic state, while RLIs normally need at least a minimum amount of metal loss before they can see something.
Okay, good. We've got another few questions coming in on the capability of the E2, and the question here is relating to corrosion-resistant alloys. So, will it work on corrosion-resistant alloys?
I'll offer that one to Hamid.
That's okay, Jim. Yeah, if we are talking about the pipe material, obviously one of the limitations here is we need magnetic, ferromagnetic material for the pipe itself. But if we're talking about cladding and something shielding the pipe or insulation, normally if they are non-magnetic, it won't interfere with the Focused City results. But yeah, if it is the pipe itself, if it is not magnetic, we shouldn't see anything. That's again one of the examples why we need a bigger database. We need more field surveys, if you like, to gather more data before we can answer these questions more confidently.
Okay. So would you expect that when you develop the tool and when you develop the technique that you can refine the signal analysis part so that you potentially could find, so one of the CUI effects on corrosion resistant alloys is cracking. So would you be able to potentially find that? Because that would be a disturbance, I guess, on your field.
Well, if I'm not expert in this field, but I guess most of CRAs are not magnetic. So if they are like completely non-magnetic, at the moment it doesn't seem feasible. However, we can investigate further. But if they are magnetic but weaker, like paramagnetic materials, then yes, definitely further investigation would lead into that. If we reduce the amount of noise, we improve the data analysis, we still can see it. Yes.
Yeah, I think Henrik, if we can crack CUI, then that's fine. I think we'll take a great. I think we'll be quite happy with that without getting into any micro cracks and stuff like that. The other bit about the CUI and on question before that, I think they were referring to with the pigging. I think the questioner was referring more to hydrocarbon transmission pipelines rather than the more common CUI problem, which is in process pipe work, normally like spaghetti junction offshore or onshore. So we never pig them. So the application is really for spaghetti junction type pipelines, small areas, rather than as distinct from long, straight transmission, hydrocarbon transmission pipelines. I think that's maybe need to clarify.
Yeah, absolutely. Let's see. So we have a question relating to passive fire protection on structural steel, which is, for instance, dense concrete with corrosion underneath it. Is that something that the tool would be able to detect?
Not really. If it should be fine with that. Anything that's non-magnetic. However, if the concrete, if it's typically passive fire protection, will be in structural steelwork. So, you know, if we're wanting to find if there's any corrosion on structural steelwork, and it's got passive fire protection with concrete on it, first question would be, has it got reinforcing? Has it got any steel reinforcement? And if it had steel reinforcement, then we would need to look at whether it could distinguish the steel reinforcement away from the carbon steel structural member that it's protecting. So it would probably be, Mohammed, correct me if I'm wrong, but it would probably depend on some kind of trials. But it's all about being, I'll go through anything that's non-magnetic as the rule of thumb.
Okay, yeah, I think so. The question here more relates to the passive fire protection being the concrete part. So therefore it would not have reinforcement in it, but we do know that some of these use chicken wire and the likes to keep it together. So could present a problem or a challenge. One of the things that we see quite a bit is that we used brickwork, so cemented brickwork for fire protection. So I guess that would be okay for your tool.
Yeah, it would be good.
Yeah, it's just like an insulation on magnetic insulation. Yeah.
There's a question relating to live heat tracing. That's interesting. So if you've got live heat tracing, or if you've got heat tracing of any sort in your under your insulation, I guess that's something you would need to look at, or is that something you have looked at?
Not so far, I don't think, Dave. I don't think there's been any heat tracing in any of the samples we've done so far. So it probably would see a signal, but we don't know the extent of that until we would try it.
Yes, exactly. We need to test it, but obviously, if it's normally, I mean, it's copper. So if there's no current passing in, we shouldn't have any problem. Even if we see it, we see that's been extended longitudinally, so we can tell it's the wire.
Yvonne, we have a question relating to RBI. So I don't know if it's something that you want to tackle first, and then we can talk about it in the panel. So what's the panel's view on the determination of inspection frequency using risk-based approach and coverage as pertinent to the inspection of lines in the section of various diameter? So I guess all in relation to CUI. So the use of RBI for CUI.
Sorry, excuse me, I'm just kind of reading the question.
That's okay.
So can you, sorry, ask the question again?
What are the panel's view on the determination? So you can see the question. So it's 1901 question.
Okay, yes.
What's the panel's view on the determination of inspection frequency using a risk-based approach and coverage, and as it is pertinent for, and then it just flipped for me as well. Inspection of lines. So it's basically using an RBI approach for CUI inspection. How appropriate and what's our experience of it?
I think it's appropriate. You know, that is basically how it's done. You know, because RBI sort of like focuses your attention on equipment that have got higher risk of failure. You know, so you would want to inspect those first. And like in your RBI, in developing your RBI, you're looking at your likelihood or probability of failure, and you're looking at your consequence of failure. So high risk items will get inspected more often, will have more coverage than lower risk items. I don't know if that answered the question.
Okay, thank you.
Sorry for jumping in there, Henrik. Mohammed Ijaz, representing ICorr. In fact, I wouldn't say that it's whole ICorr's view on it, but it's just my personal opinion. Using the risk-based ideology is actually quite okay to start with, but I would say it's quite difficult to apply the risk-based approach directly. It would be a good idea to use it with care, because in the risk-based knowledge, you are actually inspecting and relying on the what we call the reliable UT-RAD methods. But for CUI, because the inspection in most of the cases is not that we don't have enough data there, so I would say that it's always a good idea to have it used with a pinch of salt, if that makes sense.
Yeah,
Absolutely.
It does. I can add that, we're talking about a portable tool, and it could be applied locally. It doesn't have to cover the entire section of the pipe. So it could be used as a screening for RBI, not for planning for it. So, you can, if there is a high risk area, you can inspect that area and just move on. And you don't have to inspect the entire length of the pipeline every year. For example, you can repeat this every 6 months on a high risk areas. In that respect, I think it would help.
Yeah.
I think from my perspective, I think data analytics, RBI, is really crucial to helping us solve this problem once and for all, or help manage the problem, not solve it, because I think we've talked about this in the fact that we know how to fix it, but there's challenges with budgets, access, etc., etc. So RBI has its place. I think the more data we can share, if we can standardize data across the different operators, the different recovery techniques for however we're gathering that data, and having the biggest pool that we can to understand the common and not so common failure modes, the degradation methods, what we're seeing in different areas of the plant, and starting to really look upon the lessons learned aspects, because we don't talk about CUI on a regular basis. We know roughly where it's going to occur. We do predict, we do use RBI to focus our efforts. But if you can imagine doing that across one operator to two operators, downstream, upstream, across the whole network, then we will have a very powerful, hopefully, database then that others can then start tapping into, from the data science point of view. And I think that's maybe part of why the CUI network's been brought back to fruition, to say, let's start talking about this as a collective. We use the word collaboration on lots of occasions, and maybe, some people are now saying, oh, we don't want to use that word, but actually maybe this is an opportunity where we can share a lot of the data and the RBI methods that we've been using to see how we can just manage it more effectively.
Absolutely, and there's an awful lot of data out there with individual operators, with individual contractors, which is it was very difficult to share, but with modern data analysis methods and AI and all this, it is a lot easier nowadays, and it's actually doable. So yeah, absolutely, a good way to go. We have a question regarding insulation material. And so the question is, I'm interested to hear if there's anything new development in terms of insulation materials that can offer appropriate heat preservation as opposed to the current commonly used materials where we see CUI after about 10-15 years. Rebecca, has anybody been to you with CUI material type, with insulation material type developments?
Again, it's not an area we've seen a huge amount of development in. I think there's always been just around that traditional approach. Again, it has been interesting to see some of the feedback we've had from the operator community to say, we should be looking at this at design phase I know we're not doing a lot of new build or redesigning at the moment, but we should be considering, you know, alternative or newer type materials that may have an increased outlay. The capital expenditure may be increased because of these new materials do come usually with a cost associated with them. But if you then start looking at the whole life cycle piece, then it obviously does play into it. So it is an area, it's a technology gap in the whole CUI space that I do believe should be worked on. I know we talk about it over the 4 different areas, the data prediction, to the condition monitoring, to the inspection, and the repair mitigation alternatives needs to be addressed as well. And that doesn't always fall into the integrity engineer scope. And it's, oh, well, it's into maintenance and those guys. So I know there's been a few discussions on the chat about, you know, where's the duty holders? Are they not stepping up to the plate? You know, they are. I'm not criticising the industry. I think we just need to join up all the different dots, and we might actually get a better outcome. And also just raise it on the agenda with maybe the budget holders, the asset managers, to say, because CUI sometimes just falls through the gaps, and until you have a failure, it's always seen as a huge cost and drain on resource, and half the time we don't find anything. So I just think, yeah, if we join up a lot of the dots, we may actually get a bit more progress.
Yeah. For the Vegan from DNV Norway has added a comment in saying that regarding the insulating materials common in Norway, aerogels are used to a large extent by major operators in Norway. And I know it has been trialed at various sites in the UK as well. I guess one of the big issues that we see from an operator point of view is that the minute you cover up the pipe in anything, you need to look underneath it from time to time to figure out whether the pipe is okay. And then you're back to the same problem that we have. We need to be able to detect. So,
or develop see-through insulation. If you have it see-through, problem's gone.
Go. Absolutely. It can be done, but I don't think it's commercialized as yet. But that could be a good idea.
Mm-hmm.
Okay. One of the other issues that's been raised in the conversation is again back to the tool, back to the FSCT tool, and is there any sort of temperature limitations? Does the magnetism change or anything like that? Is that something that you're looking at?
It's not in the plan at the moment, Henrik, to look at temperatures. I have no idea whether the magnetic field would be changed. I wouldn't think it would be changed that much by the temperature. Certainly in the ranges that we're talking about in oil and gas applications. But maybe Dave or Hamid has a comment on that.
Completely agree. If you're talking about the stress due to heat, high heat, yes, I think we should be able to see it. But the impact of heat, as James said, in those range like 100 degrees, 200 degrees, I don't think we should have any issues. Unless we have problem with the enclosure of the probe, which is something we can solve it quickly.
Okay. So another comment that's come up is that another prevailing challenge on mature assets is a combination of old and new insulation materials technology, which creates a conundrum when it comes to analysis of CUI susceptibility. Any thought from the panel on the mixture of new and old insulation material that we got out there?
For the technology that we're developing, it wouldn't matter if it was old or the age of the insulation. It would only matter if it was magnetic or not, Henrik. So it would be as simple as that. But it would probably be better someone else taking that question up, maybe to talk about whether it would be a problem in as far as risk-based assessment of it.
I think one of the challenges you do have when you've got a mixture of materials, especially with new materials coming through, is some of the existing inspection techniques. How does that influence it? So, you know, we might not always have the case studies or the history to understand if so tech or radiography, does those different materials influence the results? Because obviously if you're used to certain materials and you've done lots of testing and lots of trials, then bringing in new materials can also then pose a challenge on the sense, well, how confident are we on the results? And yeah, I think that's where the data, the lessons, the analytics side from the prediction also will help that type of challenge. But again, it comes down to all of this, and it is about that retrofitting and looking at, do you have to replace the whole system, or are you better just having this mismatch and just managing it accordingly, depending on the age of the plant, because that comes into your decision making and your risks at late life. So not an easy one to solve, I would say. I think it is a headache.
Absolutely, it is definitely a headache, and we know from our facilities that some of the very old onshore facilities, they got galvanized carbon steel insulation, and then of course Jim's tool is out the door because it'll only see the outside of the insulation plate. So it is an area, but one of the things that we use, and just to put a bit of my personal experience in, so one of the things that we use the type of insulation to gauge when it's last off, and then we know how it fits in with an RBI program and whether we should actually go there, because we haven't been there for a long time. So it does help us to some extent as well. Okay. In terms of the CUI moving into a more data collecting area, is there anything that OGTC is doing at the moment in that area? Is there anything that we can collaborate around?
So we have a couple of proposals that are under development. I obviously can't talk about those due to confidentiality because they're still in the planning phase, but we are looking at that. It has been a focus for us over the last 6 months, and because we've got a lot of inspection techniques coming through the system and some of the monitoring techniques, we obviously felt this was a gap. So we have been working with a couple of companies in that space. Hopefully we're in the final stage of review and approval of those. Once they are approved, then we may go out to industry and ask for participants to support those with the data, because they will need as much data sets. But the companies that are working with us on those proposals are actually, you know, in the integrity management space. They are working with operators, so they will bring their own sort of ask to the people they're working with as well. So it is something I would say watch this space, and hopefully in the next sort of month or so we'll be able to make announcements on project activity in this. But certainly, yes, the challenge of data and the prediction side, I think, will hopefully make some inroads into some of the detection and being able to focus our efforts.
Okay, thank you very much, Rebecca. And we have a question to the whole panel. So what is your favorite technique, NDT technique, for detecting CUI? So let's go around the panel. Rebecca, do you want to start?
I'm going to cheat and say there is not one technique that fits every box. And I think you all have to understand the limitations, and there is not a silver bullet out there. So PEC's good for some, radiography is good, visual inspection is good. They all work, but they all have to work in combination with each other. So I kind of cheated there.
You picked them all.
Yes, because they all have their place.
Okay, and Yvonne, what would you pick as your favorite technique for CUI detection?
Yes, I agree, or I concur with Rebecca. You know, They all have, advantages, disadvantages. I love the old-fashioned way of, stripping insulation and carrying out, visual inspection, because it's, for me, it's still the most effective way. But then there is still room for NII, and with technology getting better, I believe a suitable technique will be found. They are suitable NII techniques, but a more suitable one will be found. That's my answer.
Thank you.
Actually, I'm going to add to that. My favourite one, and just to bring a bit of humour to it, is the sniffer dogs. Remember when we were going to put dogs offshore? That would be my one.
Yes.
The cutest one we had so far, that's for sure. Jim, you got a lot of experience with lots of different techniques, so
I don't really see it as being that difficult, to be honest. I don't. Certainly this technology we're talking about just now is the nearest I've seen to a silver bullet that I've seen in all the NDT techniques that I've come across, or as close as I've seen to anything I've seen so far. If it does what it says on the tin, the point at the moment is we're still writing the label for that tin. So if it does what we think it'll do, then it will be a major step change in CUI. I think it'll be a major step change. But it all comes down to the operators like you, Henrik. It's all about what you trust. And, what do you trust a series of wavy lines that some expert tells you is this or is that? Or do you trust an X-ray, for example? And a lot of people will always default to OK X-ray, and we'll really see what's happening. So we've tried to, certainly within Oceaneering, go into a space where we're using as much radiation techniques because they're trusted in inverted commas more than anything else. Plus, we're trying to do away or getting less and less dangerous radiation exposure systems and more sensitive sensors, which means we might be getting down to 2 seconds maximum per exposure. And you'll be able to get all the information you need in that type of thing. But obviously it's an area coverage rather than a longer pipe coverage, which would be more obvious for guided waves.
Okay. So apologies to Hamid and Dave, but in the interest of time, we'll push on, and I'd like to thank everybody for their participation tonight and for the question, the panelists, and then I'd like to hand over to Dr. Ijaz, who's the chair of ICorr, for the closing remarks.
Cheers. Thank you very much, Henrik. Much appreciated. With that, I would like to thank everyone who was working in the background, Katrina and everybody on the Energy Institute, Aberdeen, Highlands and Islands team, everybody who was working from the ICorr side, Stephen Tate, Human, and a few others. Whole committee actually was working towards, but the most thanks goes to actually the Energy Institute Aberdeen branch for hosting the event for today, and the presenters, of course, who has done the excellent job there. So I will actually provide a brief outlook and just brief intro to the ICorr, and with that, I would say that it's actually quite busy and quite hectic schedule for us this year, since we have gone to webinar and we have been settling in very well. ICorr Aberdeen branch has been quite successful actually in producing quite few webinars, especially one of the series we had with MCF twice this year, actually 2 weeks of full runs, and we are settling in very well. If you are not receiving any of the invitations, please go on our official website, icorr.org/Aberdeen, and we usually put all the resources, any of the presentation and historic presentation, on ICorr ABZ Resource Center in Google site, which is actually being moved to ICorr Aberdeen for now, but actually all the old resources are still there. We have started actually recording all the events and putting them on YouTube channel, which is available here. And all the invitations are actually advertised on LinkedIn, as well as put forward to all of our email list. With that, I would like to actually just pay our respect and regards for our actually all our sponsors, branch sponsors, and all other sponsors, without whom we wouldn't be able to do any of the good work we are doing, because we are volunteers, most of us anyway. And with all of those sponsors, we are actually providing quite a good technical program. And it wouldn't be right for me to thank anybody else apart from the committee on the screen today. Actually, these are very active people. If you look at the faces, you will see good 250 years of corrosion experience plus, or a little bit around there. Few of us has got quite a lot of experience there. But this is our committee for this year, and if you haven't been in contact with us for any of the invitations, any of the sponsorship, please feel free to contact any of us, me, Human, Steve, Nigel, Zara, or Bryn. All are quite known corrosion engineer in Aberdeen arena. I would like to invite all of you, including ICorr members, non-members, to our next event, which is going to be on 23rd of February 2021. The topic is delivering real-time condition monitoring of subsea pipelines. Hopefully, it's going to be very, very interesting topic presented by Rob Hardy, who's commercial manager of Tresico. And with that, I would like to thank all of you for attending, without whom we wouldn't be actually here. So thank you for attending. Thanks to Henrik and the panel, much appreciated. I'll give back the screen to Henrik to take over.
Okay, thank you to everybody, and that completes tonight's interesting conversations around CUI. Thank you.